Welcome to yet another Power BI tutorial from MIPE Consulting. A Power BI certified custom scatter plot visual developed by MIPE Consulting is available in the Microsoft App Source. This is the custom scatter plot available in the App Source of Microsoft. It's a custom scatter plot with 3 customizable zones. The description reads like this. This visual enables you to visualize your business data into an intelligent scatter plot based on an X dimension as well as a Y dimension. Design your business rules and implement them into the visual through a simple drag and drop in order to analyze the performance of your products. Have a better understanding of top performers and low performers amongst your data thanks to a unique system with 3 customizable zones as good, medium, and bad. The position and size of each zone can be different according to each of your products. You can have a feel of how the custom scatter plot visual looks when you put it to use. It's free of cost and you can get it by clicking here. In this video, we are going to see how to use the custom scatter plot visual in the automobile industry. Let's begin. The data that we are going to use for this illustration is the fuel consumption ratings data available in the Canadian government website, which is shown here. As we scroll down on page number 5, we can see 2020 fuel consumption ratings as of 25th of September 2020, and the data set is available in CSV in English. You can download the database by clicking on the Access button, and the data is also available in French. I have downloaded this data and let's have a look at that. The name of the Excel file is My 2020 Fuel Consumption Ratings. This contains the data pertaining to various car models of 39 different manufacturers. All the models have the model year 2020, and the data consists of model year, make, model, vehicle class, engine size, cylinders, transmission, fuel type, fuel consumption city, liters per 100 kilometers, fuel consumption highway, liters per 100 kilometers, and fuel consumption combined between city and highway, miles per gallon, carbon dioxide emission grams per kilometer, carbon dioxide rating in a scale of 1 to 10, and smog rating in a scale of 1 to 10. And what does this COM mean? Let's look at the information provided. You can look at expansion of the acronyms used. In the fuel consumption, it is mentioned that the combined rating takes into account 55% of city and 45% of highway fuel consumption. So for the purpose of this video, I have extracted the data pertaining to 20 major manufacturers, which is representative of all permutations and combinations. The data that is available here will be used to categorize the vehicles into good, medium, and bad, and use the custom scatter plot to display the good, medium, bad in the green, yellow, and red zones respectively. Let's see how we can do that. Let's have a look at the requirements of the custom scatter plot. In the custom scatter plot, the first requirement is an aggregation column. This column should uniquely identify each row of the dataset. Then we need a column for the x-axis, another column for the y-axis. We have x limit 1, x limit 2, x limit 3, which would be 3 limits for the x-axis, 1 for the red zone, 1 for the yellow zone, and 1 for the green zone. And we need y limit 1 and y limit 2. So we need 2 limits for the y-axis, y limit 1 and y limit 2. We shall see how to create rules for evaluating x limit 1, 2, 3, y limit 1 and 2 from the dataset. Let's go to the dataset. Here we have formulated the rules with the intention of classifying all the vehicle models into these 3 zones. The green zone will be those vehicle models that have carbon dioxide emissions less than 165 grams. And the orange zone will consist of vehicle models that have carbon dioxide emissions between 165 and 245. And the red zone will consist of vehicle models that have carbon dioxide emissions greater than 245. With this goal in mind, we have formulated rules for the X limit 1, X limit 2, X limit 3, Y limit 1, and Y limit 2. The Y limit 1 value for all the vehicle makes and models would be 165. The Y limit 2 for all the vehicle makes and models will be 245. The X limit 2 will be 0 for all vehicle makes and models. X limit 3 will be the same as X limit 1 for all vehicle makes and models. Now, the only thing that we have to calculate is X limit 1 for all the three categories. X limit 1 we are going to calculate by taking the maximum of fuel consumption COM MPG. In this dataset, you can see the fuel consumption COM MPG. Along the x-axis of the scatter plot, we are going to plot fuel consumption COM MPG. And along the y-axis, we are going to have the carbon dioxide emissions in grams. The values 165 and 245 have been arrived at based on the carbon dioxide rating column given in the dataset. Now we go back to the rules. For finding out X limit 1 for carbon dioxide emissions less than 165. First of all, we filter all the vehicle models that have carbon dioxide emissions less than 165 and find the maximum value of the fuel consumption COM MPG and add 1 to that. Example, if the maximum value of fuel consumption amongst all models having carbon dioxide emission greater than 165 is 35, the X limit 1 would be 36. Similarly, for carbon dioxide emissions greater than or equal to 165 and less than or equal to 245, we filter all those vehicle models that have carbon dioxide emissions in the range of 165 to 245 and find out the minimum value of fuel consumption COM MPG. Example, if the minimum value of fuel consumption among all models having carbon dioxide emission greater than or equal to 165 and less than 245 is 35, X limit would be 34. Similarly, for all those models that have carbon dioxide emissions greater than 245, we take the maximum value of fuel consumption COM MPG, add 1 to that. So if the maximum value of fuel consumption among all models having carbon dioxide emissions greater than 245 is 35, the X limit 1 would be 36. So based on these rules, we are going to create the custom scatter plot visual. Let's go to Power BI and import this dataset. We are in Power BI desktop and let's import the Excel file containing the fuel consumption data into Power BI. Click on Get Data. It's an Excel file, so click on Excel. Next, this is the file that we want to import. Click on Open. We have 3 tables. We need only the data table. Let's select that and click on Transform Data because we need to make some transformations. So we have the data in Power BI. Let's choose only the columns that we need. So click on Choose Columns, and let me deselect all columns and select whatever I need. So go to Make, Model, Vehicle Class, Engine Size, probably we can include Transmission. Then we need Fuel Consumption, COM, MPG, Carbon Dioxide Emissions. Maybe we can keep the carbon dioxide rating. That's all we need, and let's click on OK. Now we are going to create an index column so that each model of the vehicle can be uniquely identified using that column. For that, go to Add Column, click on Index Column, and we start numbering from 1, and a new column index has been created. Let's rename this as Model Index so that we can understand that this uniquely identifies the model of each vehicle. We are going to create another column which combines the vehicle class and the engine size. So let's select both these columns. This new column will help us filter a make by vehicle class and engine size. Let's create a column from examples. Click on Column from Examples, and from Selection because we need the new column to be based on these 2 columns. So click on From Selection. We have the column here. Let's name it as Class and Engine Size. Let's create the first row as Subcompact 2, which is a combination of Subcompact, which is the vehicle class, and the size of the engine 2 liters. So let's click on OK. And we can see that we don't have any blank columns. So we can understand that the command has been executed correctly. Let's create 3 more columns, x limit 2, y limit 1, and y limit 2. Those columns will have constant values. So let's go to add column, let's say custom column, and let's put the column name as x limit 2, and let's initialize it with a 0 value. All the rows in this column will have a value 0. Let's put equal to 0, click on OK. So we have a column which has got all 0 values. So let's create 2 more custom columns, add column, custom column. The next column will be y limit 1, and the value in this column would be 165. Click on OK. So we have the column here. Create 1 more, y limit 2, and let's put the value as 245. Click on OK. This is all that is to be done in the transformation. So let's go to home, close and apply, close and apply. We need to create 2 more columns, x limit 1 and x limit 3. For creating x limit 1, we are going to use a DAX formula. Click on data, click on new column. Let's name the column as x limit 1, and this column will be created based on the rules that we saw earlier. We can have a look at the rules once more. For x limit 1, we have to calculate a maximum of fuel consumption COM for all those rows whose carbon dioxide emissions are less than 165, min value for the second rule and max value for the third rule. We shall convert it into a DAX formula and create the column. Let's see how we can do that. In the DAX expression that we are going to use to create the new column x limit 1, we are going to use 3 functions, switch, maxx, and minx. Let's have a look at what these functions do. The switch function evaluates an expression against a list of values and returns one of multiple possible result expressions. Let's have a look at an example. Switch month 1 January, 2 February, 3 March, and so on. And if it is none of these numbers, it should return unknown number, which means that in the month column, if the value is 1, it would return January. If the value is 2, it would return February. And if doesn't match any of these numbers, it would return unknown month number. So the next expression that we are going to use is maxx. The maxx evaluates an expression for each row of a table and returns the largest value. Let's see an example. In example 2, the following formula, the maxx formula, first filters the table internet sales. So maxx filter internet sales, this is the table name, by using a filter expression to return a subset of orders for a specific sales region defined as sales territory equals 5. So this returns all the internet sales for sales territory code equals 5. The maxx function then evaluates the expression used as a second argument for each row of the filter table. So after filtering this table, for each row of the filter table, it will evaluate this expression. That is, internet sales is the table name, tax amount plus freight. These 2 columns will be added and the value will be returned for each row. The minx function does the same thing. Minx returns the smallest value that results from evaluating an expression for each row of a table. Example, the following example uses the same filter table as the previous example, but instead of merely looking at values in the column for each row of the filter table, the function calculates sum of 2 columns, freight and tax amount, and returns the smallest value. So the minx function first filters the internet sales table where the sales territory key equals 5, and then adds up the freight column and the tax amount column and returns the minimum value for that sum. So let's go to Power BI and then let's create the X limit. Let me copy this formula, paste it there. So what it does is switch if carbon dioxide emissions is less than 165, find out the maximum value after filtering all those rows for which the carbon dioxide emission is less than 165 and return the maximum value of fuel consumption COM MPG plus 1. So filter this first, then find out the maximum value of fuel consumption COM MPG. Then that will be returned and 1 will be added to that value. Similarly, for the next rule, where carbon dioxide emissions are between 165 and 245, the data table will be filtered for all those rows where the carbon dioxide emission is between 165 and 245, and the minimum value will be calculated and 1 will be subtracted from that. Similarly, for carbon dioxide emissions greater than 245, filtering will be done first, maximum value will be evaluated, 1 will be added, and that will be returned. So let's press enter and we can see that the column X limit 1 has been created. Now we have to create one more column, which is X limit 3. So let's click on data again, click on new column and let's name it as X limit 3. And as per our rules, the value of X limit 3 in all the cases is the same as X limit 1. So what we'll do is we'll say that X limit 3 is equal to X limit 1. Press the enter key. We've created X limit 3 also. So we have all the necessary columns required to create the custom scatterplot visual. We have to first of all get the custom scatterplot visual. So let's go to get more visuals. Get more visuals here. Let's select all and then type my, or you can type custom scatterplot. And you can see custom scatterplot here and click on add. So we have added the custom scatterplot visual here. Click on OK. We are going to import one more custom visual, which is called hierarchy slicer. So let's click here, get more visuals, click on all, click on hierarchy slicer. This is the hierarchy slicer that we want. Click on add. So it's been imported here. Let's click on OK. Now, first of all, let's click on this. So we have the visual here. Then in the aggregate column, we can drag and drop the model index because this uniquely identifies each model. Along the x-axis, we will put fuel consumption COM MPG. Along the y-axis, we shall drag and drop carbon dioxide emissions. Under the X limit 1, we can drag and drop X limit 1. Under X limit 2, we can drag and drop X limit 2. X limit 3, we can drag and drop X limit 3. Similarly for Y limit 1 and Y limit 2. So we can see the custom scatter plot being populated for all makes and models for all the cars in the dataset. Now let's use slicers to visualize this properly, and before that we have to do a bit of formatting. So let's go to the format icon, click on parameters, and here you see call 341, call 1, call 3. The 1, 2, 3, 4, 5 that you see here are the model index numbers. Instead of having call here, we can put model number here so that it will be more appropriate. So you have model number 1, model number 2, etc., which indicates the model index number, which in turn points to the model. Now we can control the display here. For that, we are going to create the hierarchy slicer as well as a table visual. So let's click on the hierarchy slicer. Under the fields, let's drag and drop make and class and engine size. We can see a minus sign and a plus sign. The minus sign is for collapsing and the plus sign is for expanding. So let's click on expand all, and under every make, you can see the vehicle class plus the engine size. So if you click on compact 2, you can see the model here. Click on compact 3, you can see the model here, and you can see that it is within the yellow zone. let's click on mid-size 2.9 and you can see two models here. And if I click on the focus mode, you will be able to see it better. Both the models are overlapping here. Maybe we can try more. You can see two models overlapping here. Two-seater one, you can see it here. And SUV standard 4, you can see three models here in the red zone. If I click on the make name, you can see all the models being shown here. You have a load of them in the red zone and a few of them in the yellow zone. Maybe you can try this with BMW and you can see the distribution of models according to the carbon dioxide emissions in the red and yellow zones. You can try this with all makes, and in the case of Ford, you can see a few in the green zone too. In case you want to see a few more details, like the model number, etc., we can create another visual, which is a table visual. Let's click on the table visual. Under the values, let's drag and drop the model index number and right click on this. Click on Don't Summarize so that we can see the model index numbers. We can add the make underneath that and we can add the model. Let's click on Toyota and see how the models fare. You can see quite a few in the red zone and some in the green zone. Let's expand this and try some of the models. Let's go for the two-seater 3. You can see it in the yellow zone. Then standard 5.7, you can see it in the red zone. You can see the model number here. And the model index, which is indicated here, is what is shown here. If I put it in the focus mode, you can see the model number here as 642. And you can see the model figuring in the red zone. One thing which we can see is that as the engine size increases, the tendency of the model is to go into the red zone. Here too, you have two and both are figuring in the red zone, more or less overlapping. You have both of these figuring in the green zone. You can see that the engine sizes come down to 2.5 and therefore the carbon dioxide emission is less. In case I want to start an automobile showroom and want to focus on environmental friendly cars, I can use this custom scatterplot visual to see which models are doing well and focus on those models. Or if I want to purchase a vehicle, I can do the same thing. If I'm a big business and want to own a fleet of cars and I'm interested in environmental friendly cars, I can use this custom scatterplot visual to look at models that are doing well and then purchase those. This custom scatterplot can help us make the earth greener. Hope you found this video useful. We at MIPE value your feedback a lot. Thank you very much and see you again with another Power BI tutorial.